Hello, everyone. So welcome to our webinar of 3D stereo camera hosted by Leopard Imaging and eYs3D. Also, happy Lunar New Year of Ox. We wish everyone to enjoy a bull market and as healthy as an ox this year. Well, that's very important. So to begin our presentation, I'd like to first introduce today's host to you. This is Kathy Zhao. I'm the product marketing manager from Leopard Imaging, and also our software engineer, Adrian Hao. We also have co-hosts from eYs3D. John, can you introduce yourself to our audience?
Hi, yes. Hi, good morning, everyone. This is John Lin from eYs3D, and I'm the director of the technical marketing and the BD. So nice meeting you over the webinar.
Thank you, John. Recently, Leopard Imaging has released new stereo cameras powered by eYs3D, and both companies are also working on new stereo camera projects. One is Gmsl stereo camera, and the other one is PoE stereo camera. Many of our customers are quite interested in our new cameras. So today, John and I will together take you on a tour of stereo cameras and go deep into our stereo sensing technologies. Before our presentation, I recommend anyone who has questions during the presentation, please put your question on the Zoom chat so we can later answer them in our Q&A session. Based on our agenda, I will first briefly introduce Leopard Imaging and our depth cameras to you. Then John and I will take you on a tour of our most recent stereo cameras powered by eYs3D and our new projects. After that, John will talk about eYs3D, the company, its products, and we will go deep into stereo sensing technologies. If you have any questions, John, Adrian, and I are happy to answer your questions after that. All right. So to begin with, I would like to first introduce Leopard Imaging briefly. So Leopard Imaging was established in the year 2008 in Fremont, California. We're a global lead in providing high definition embedded cameras with OEM and ODM services, thermal camera, AI edge computing solutions, and other camera solutions. We have worked in the fields of autonomous driving, drones, IoT, robotics, AR/VR, AI-related products, and so on. Some well-known products we have worked on, including the cameras on the autonomous cars, such as Zoox, Baidu, Pepper robots, on IoT smart cities in Canada, like cleaning robots, which are being used in Sam's Clubs right now. Also on drones from FLIR, Enduro, Amazon, and many other well-known products. We have 3 offices and a new campus being built in Nantong, China. So our original office is in Fremont, US, and we welcome everyone to go to our huge new campus in Nantong when the pandemic is gone. Yeah, so keep safe at this moment. In terms of partners, besides eYs3D, we are NVIDIA preferred partner, a member of Amazon Partner Network. We work with AWS and also provide cameras for Amazon Prime Air drones and Amazon autonomous cars. And this year, we started to work with Microsoft on 3D ToF cameras. Our partners also include Sony, Qualcomm, and other major sensor companies. So in terms of our customers, we worked with Amazon, Google, Facebook, Daimler, Baidu, and famous research institutes such as Boston Dynamics. We have designed and manufactured cameras for many companies and institutes. Now, I'd like to take a tour with you to explore our 3D depth cameras. I think that everyone here already knows something about 3D depth cameras. You know, like a depth camera captures depth images and a depth image indicates in each pixel the distance from the camera to the seen object. Among the sensor fusion depth sensing technologies, the most popular technologies are time of flight, which is TOF depth sensing, structured light depth sensing, and stereo vision depth sensing, which is what we are going to talk more about today. And here are some modules of depth cameras with these three kinds of technology. If you have a look at of the markets of 3D depth cameras, you will find that the most cameras are applied in retail, transportation, healthcare, smart home, and manufacturing automation industries. John later will go deep into the 3D depth camera industries later. And Leopard Imaging has developed stereo cameras and TOF cameras for years, which you can see on our website. And if you have any questions, welcome to email us. Just actually 3 weeks ago, we announced our collaboration with Microsoft on TOF camera development. In this project, we will connect with Microsoft Azure Cloud Platform. And now comes the most important part of today to explore our stereo cameras powered by eYs3D. Let's first watch the video to have some general idea of those three stereo cameras. Actually, all these three stereo cameras are capable of measuring distance and creating the data necessary for point cloud calculations. For each of them, in the video, we can see the differences in terms of video resolution, frame rate, horizontal and vertical FOV of those cameras. And if we look at other parameters and use cases of those three cameras, we will find that the first one, that's the Leopard Imaging VGA3D 63H camera. It has a 3 centimeter baseline and VGA RGB and depth output resolution 3D camera for lightweight and close-up 3D sensing design, such as wearable and 3D camera on the phone. And also for the Leopard Imaging HD3D 115H camera. It has a 6 centimeter baseline, 100-degree FOV with HD RGB and depth output resolution 3D camera for fast motion depth sensing and scanning in mobile robots. And the last one is a Leopard Imaging HD 3D 56H camera. So it also has a baseline of 6 centimeters, 50-degree FOV with HD RGB and depth output resolution 3D camera for motion or static scene, and object recognition requires higher accuracy. If you want to learn more about the 3D stereo sensing technologies related to these 3 cameras, John later will give us more explanations. Also, besides the 3 cameras, Leopard Imaging and eYs3D are also working on 2 stereo camera projects. So the collaborative projects of Gmsl and PoE stereo 3D camera, Leopard Imaging is retrofitting 3D stereo cameras of eYs3D to Gmsl2 and Ethernet RG45, which is PoE interface, with dust and water resistance housing IP65 industrial standard complaint. So let's look at the first one, the Gmsl stereo camera project. The 8062 Gmsl stereo 3D camera has IMU on board, enable VSLAM function for mobile robot, such as service robot, AGV or AMR, and goods to person, that's G2P, in fast motion or object scanning and other uses. And the second project, the 8055 RG45, which is PoE stereo 3D camera, has higher depth accuracy over in-wire power RG45 cable that is suitable for machine version such as robotics, cobalt, eye-in-hand camera systems, and other uses. So now I'm going to let John introduce eYs3D and go deeper into stereo sensing technology. John, are you ready?
Yes.
Okay.
Thank you, Leopard Imaging and Kathy, hosting this webinar to introduce the 3D stereo cameras. And again, this is John Lin from eYs3D. I'm the director of the technical marketing and BD. So here's the contact information. If you would like to contact me and learn more about our products. Okay. eYs3D is a fabulous IC design company, and we are target at position us as a silicon-centric AI company. And eYs3D currently have like a 50-ish employee worldwide, headquarters located in Taiwan. And we have office in China as well as in US, where I'm located. And we value our products technology. So we constantly filing our IPs to patents and to protect our products and knowledge base. So we have 85 plus patents granted, and there are more coming in the pipeline. So our products focus, we are in the silicon driven. So we have ISP, image processing, processing ICs, some developing processing technology, and depth map calculation processors. And we also, since the stereo 3D camera our customer base. So so we kind of work with our customer to customize different kind of stereoscopic 3D sense cameras based on their requirement. And for the coverage areas, as you can see, or from Kathy's presentation, there are very broad marketplace that we can address to, like a VR, AR, robotic, industrial, AIoT, healthcare, retail, and so on. But right now we are more focused on the VR, MR, and robotic and AIoT area. And our product and service are, since we're an IC design company, we definitely offer our silicon ICs to our customers for their design. In the meantime, if customers would like to have some subsystems based on our ICs, we can also provide full customizations designs. And we also have some other products like sensors, and also the IR projector, dot projector, and development platform, things like that is coming in this year. And here's the landscape or the overview of our i3D's ICs. The categories being in depth map processor and developing processor and spherical processors. And here's our some product series. And like I mentioned earlier, that in order to validate or having it easier for customer to hands-on the technology, we also produce quite a different flavors of the 3D cameras. So the basic ideas for the stereoscopic cameras is we turn the imagings to the sensing process. So here's the basic block diagram or processing pipeline for our 3D processors, ESP876. So the chips can accept two image coming in the ICs, and we kind of align two images, and inside the chips, we can based on the triangulation and come up the by pixel depth information for USB or MIPI output. And here's another more depth block diagram, how stereo vision turn two images become the depth map information. I would like to highlight a little bit more is on this page is if you have I believe most of you have known the 3D technology, including the stereo vision. So if you would like to, there are many papers or or information you can find it online. But I'm more than happy to answer you further question about this technology if in the Q&A section or later on. And For the stereoscopic camera, here's one of the products that we produce. And on the right-hand side is the general camera's features. And the parameters, the more important parameters for the stereoscopic camera are the baseline. The baseline means the distance between two image sensors. The theory of the stereoscopic camera, 3D camera, is that based on our two eyes, is we capture two images and use the triangulation process to come up the by pixel depth information. For human being, we use brain, but in the camera, this camera, we use i3D's 3D processors. And besides the baseline, you want also see what's the FOV, field of view, that you want to see, and how wide the viewing angle for your camera. And another one is our projector. We are even though we use the natural light to capture images for 3D depth data calculation, but we also use IR projector as the assistant, reference point, dot point, so we can provide more accurate way to for the depth information. And another component is IMU, initial measurement unit, that allows the camera to also report some acceleration or velocity information along with the stereo images and the depth. So this is good for VSLAM or VI-SLAMs applications. And besides the IMU, the standard output interface for our camera is USB output, and the USB output is the standard USB 3.2 Gen 1 or USB 2, and it's the and for multiple camera, you can also connect multiple camera together to sync up their image capture frames. So these are the parameters that you can examine or help you to select the right stereoscopic camera. And here are some flavors from our camera selections. Okay, thank you. I'm back to Kathy.
Thank you, John. And actually, John, I have some questions to further our 3D sensing camera discussion.
Okay.
And also, if anyone in the audience, you have any questions, please feel free to put it in the chat, and we will answer them together in the Q&A session. Mm-hmm. So John, actually, in my presentation, I mentioned about the most popular 3D sensing technologies in the market. So what are their pros and cons? Can you explain more?
Okay, sure. Okay, so you just mentioned that there are three types of the like a sensor-based 3D sensors.
Yes.
So I would like to rephrase that. There's no perfect, since this is not like our raw eyes. There's no perfect 3D sensing camera in the market. That's why there are different kind of camera like different kind of 3D sensing technology like stereo vision or structured light or time of flight. So I would like to bring up this like a sensor fusion concepts. If your applications suitable for stereo vision, that's great. And time of flight is also good at in some aspect. So in the system, you sometimes people implement not only one 3D sensing technology, but also use different kind of like a mix type of the 3D sensing technology. So here I just compare three sensing 3D sensing technology, and basically they just output the depth map, like you said, depth map information and the RGB information for point cloud constructions. And for the stereo, as you can see, for the stereo vision plus IR, they are good for short range and good XY resolution because they use the standard image sensor like a 5 megapixels, 2 megapixels type of image sensors. And the time of flight for the short range, what I addressed here, good for long range because the short range because of the light traveling time so fast. Sometimes for the short range accuracy might be vary. And for the environment consideration, like for outdoors, because stereo image is good for is using the natural light for sensing and 3D creation. So the better lighting is good for is better for stereo vision. And in overall, let me pull to the bottom here. So the overall, the advantage for the stereo vision is good resolution because they use the, like I said earlier, they use the standard image sensors for detection. And for the time of flight, right now I believe they the more popular resolution is QVGA, but I think down the road they are producing higher resolution of the sensor, top sensors. And also in terms of the disadvantage for the stereoscopic 3D camera is since it's based on the disparity of the two cameras, then the baseline depends on the baseline width, then the camera itself, structural mechanical wise, might be a little bit larger than the other two cameras.
Right. Thank you. Thank you for your explanation, John.
Mm-hmm.
I think I get better knowledge on this.
Mm-hmm.
And also, like in my presentation, I briefly talked about some like markets of application in the 3D sensing cameras.
Mm-hmm.
Can you give me like more specific like 3D sensing camera use cases in the market?
Okay. Also in your presentation, you also addressed that there are different kind of markets that can be used for 3D camera. But I would like to share with you everyone this diagram. So the stereoscopic camera itself is just the very front end sensing device. So so our for the stereoscopic camera, they generate RGB and depth data based on their their capture, and it also relies on some image recognition like a AI machine learning middleware software and hardware to carry this to process this data. For the middleware, something like an embedded system or AI computing stick or the PC, they can run some middleware software like AI-based machine learning for like people counting, sensor scene understanding, gesture recognition, or facial detection or facial recognition, that kind of middleware. So this is the middleware support part, and so the end application will relies on the combined of the sensor and the middleware platform, and come up their application like for VR AR, like for digital signage, for like a COBAR, as you mentioned earlier, the install the 3D camera on the robot arm to instead of doing the routine motion, they can adding the vision on the robot arm become more intelligent, and also like for hands-free control and so on. And here's the example of like a touchless control. This is one of our customer. They use a 3D camera for the doctor in the surgery room. So they can, so the doctor can use the 3D camera, recognize their gesture to control the display or the computer on the surgery. And another here's the another look at the 3D machine vision use case. As you can see from mobile device, computer, consumer robot, VR, AR, drone, everything are covered. As long as you need some machine vision to capture image and to combining with the AI machine learning, then there's a chance that you can use a 3D camera for your system.
Thank you, John. Yeah. Well, and as we've already talked so much about the 3D sensing cameras, let's go into the products of eYs3D. So what are the features of eYs3D sensing cameras?
Okay, sure. So we just mentioned the general idea of the algorithm behind the stereoscopic camera. We use two image sensors capture the images, and our processor will do the rectification and the global searching, semi-global searching to match the pixels, and then do the triangulations. So So this is the algorithm of the stereoscopic camera. And I also mentioned what's the key parameters for people to select the stereoscopic camera. One is the baseline. The other one is what kind of whether you want to IMU for VSLAM, and also selecting the output interface, either USB or MIPI or Gmsl, and so on. So those are the parameters that you want to look at when you select a stereoscopic camera. And from i3D, our standard camera, we offer that easy setup output mode, or so to speak, since the stereoscopic our stereoscopic camera output both our RGB data and the depth data. So our firmware inside our camera, we support different kind of output mode, combining between the video RGB data and depth data. So as you don't need to go through a very complicated programming to get what you want for the output. So we create a different kind of mode settings for the output. So another feature that offered by our camera is the Interleave Mode. As I mentioned earlier, our camera is a stereo active stereo camera. That means we use the natural light to capture the image. We also have the projector illuminator to help the depth sensing or depth calculations. However, we have this called Interleave Mode. We kind of turn the IR projector on and off alternatively, and while you are capturing the RGB data, the IR projector is turned off, so you can get a very clean RGB frame, and then the next frame will turn on the IR projector, so the processor can rely on the dot patterns to come up better depth map information. So this is the interleave mode insights of our camera. And for there's some critical issue for to match up the color image and depth information. So you can create the point cloud file or point cloud image. So we embedded the time counter on each frame on both RGB color frame as well as the depth map frame. So the host system, when they receive the RGB frame and the depth map frame, they can rely on the counter to match up and recreate the correct frame for the point cloud or 3D images. And like I mentioned earlier, one feature that support in our 3D camera is the multi-camera sync output port. So you can connect multiple cameras and one host camera, and rest of them are slaves. And you can use our SDK multi-camera control to synchronize, like a reset the counter, and across the camera link. Then you will get synchronous frame from all the connected 3D cameras. Another embedded features or selective features is Angpor Imu. So the Angpor Imu can report the velocity, can provide the velocity, orientation, and gravitational force information. So the camera can, based on this data, to tell the motion of the camera. This is good. This is one of the key feature for VSLAM's algorithm, and VSLAM is one the main features or functions for like a mobile robot or robot arm or VR, AR, that type of applications. Yeah, so those are the support feature from our cameras.
Thank you very much, John. And I will see like their audience already post on a lot of questions.
Okay.
And I will answer them later. And I saw the SDK you mentioned on the on your presentation. And what is the like software supported for eYs3D sensing cameras?
Mm-hmm. Yeah, sure. Let me share this slide here. Okay, so every camera come with the SDK. Our SDK support different OS, including Windows, Linux, and Android. So the detail supporting versions, OS versions are listed on the slide. Besides the basic SDK, we also provide the application level wrappers, such as RS, Python, OpenCV, Unity, and they are good for different domains, different domains of the application, such as the RS it's good for VSLAM real-time control integration. It is popular, is mostly used in the like a robotic control system, and like Python, as you know, in the machine learning AI related application, they use a lot of Python library. So the Python wrapper can help your AI or machine learning application, and also the OpenCV, Unity for gaming. Besides that, for the production tools, eYs3D also provide the quality test tool, debugging tool, calibration tool, and firmware update tool, and so on. Yeah.
Cool. Yeah, that's really good. And I saw there are already many questions in the chat. So let's spend the last 10 to 15 minutes to answer those questions.
Yeah.
So let me see. The first one, can Leopard Imaging tell more about TOF cameras collaborated with Microsoft? Okay, so I think that's a question for me. So for the TOF camera, though, it's like not well suiting to our today's topic, but I will just briefly answer it. So we know that Microsoft has extensive experience in like 3D tough measurements. If you ever played Xbox, then you probably have used the Kinect sensor. And at this moment, Microsoft have Azure Kinect team, which is trying to bring customers to the Azure cloud platform. And currently its intelligent depth technology is being offered as part of the HoloLens mixed reality device and the Azure Kinect development kit. So what Leopard is doing is that we will leverage Microsoft's tough technology with solutions in areas such as retail, physical security, healthcare, drones, IoT, robotics, and autonomous industries to develop the tough camera together with Microsoft. So we haven't launched the product, but I think we will launch it soon. And let's see, next question from Brad. So what is the disparity search range in pixels for the ESP876? So I think, John, that's a question for you.
So if you are talking about the precision of the disparity, we have like 10 bit, I think 11 bits of the data to represent the disparity. Mm-hmm. Is that what you are looking for?
Maybe I can unmute Brad. Let me try to unmute Brad. Brad, can you unmute yourself? Okay.
Yeah, hi. Yeah, the question is really around how many pixels your disparity search engine is searching within a row. Typically, it's like 126 pixels or something like that.
Disparity. So your question is that how do we search two images?
Yeah, when you're searching for the common point to do your disparity calculation, you have to search, left and right across a row of data. And I'm just wondering how wide of a window can you search within for the matching pixel?
Oh, yeah, that part is within inside our algorithm. So I think it's pretty standard algorithm for us. I think you're saying a 128, right? 128 pixels range.
Yeah, I mean, commonly it's in that range. But
yeah, I can confirm that with our engineers and get back to you later.
Okay, thank you.
Another question from Brad is, when will the Gmsl and PoE cameras become available for purchase? Because I believe at this moment, our two teams are collaborating together, doing experiment and developing it. So we don't have like a confirmed date to launch it, but I will say like it will be very soon. So we will let everyone know when it's available to purchase. And next question also from Brad. So how do you eliminate the projector dots from appearing in the RGB image since you don't have a dedicated RGB imager? So John, I think that's a question for you.
Yeah, I think I kind of answered in one of my slides earlier. We provide this interleave mode. Means we turn on and off the IR projector on every other frame. So so we capture the RGB frame when the IR projector is off, and capture the depth frames when the dot projector is on. So it's kind of alternated on the IR projector on and off for clean RGB and good accuracy depth map frame.
Cool. And the next question, if the IR interleave mode is the solution to eliminating the IR dots from the RGB image, you must not have IR cut filters on the lenses. So how do you prevent the sunlight IR from tinting the RGB image?
We actually have dual band IR cut filter. So in some cases, so the IR, this dual band cut filters will allow the natural lights comes in, and also let the like a 850, 830 nanometers bands lights come in. That's where the IR projectors spectrum at. So so we do have the IR cut filters for on our lenses.
All right, I think that's the end of the questions. And if you have any more questions, feel free to email us, like to Lynn. I think Lynn, Lynn, can you show your email address again? And okay. And also to Leopard Imaging. And also please follow Leopard Imaging on LinkedIn or Twitter. So when we launch our new products, you will be the first one to be noticed. For all participants, Leopard Imaging also wants to give a bonus for you. Everyone here today, or if you have a friend who is interested in the 3 cameras, like stereo cameras by Leopard Imaging, which are also powered by eYs3D, we will offer you a 10% off of the original price. And all you need to do is just to send us your name and company name to marketing@leopardimaging.com, and we will send you the promo code. And also, we really want to thank John and everyone who participated today and spent like the hour with us to explore the stereo cameras. And if you have any questions, just email us, and we expect to have another presentation on any topics you're interested in, like in the field of depth camera in the future. So thank you, everyone, and thank you, John.